हेलो स्टूडेंट्स। तो आज हम साइंस सब्जेक्ट क्लास 10th का एक रिवीजन करने वाले हैं। तो इसमें कई सारे चैप्टर आज हम कवर करने की कोशिश करेंगे। तो ये बहुत ही महत्वपूर्ण रिवीजन आपके लिए रहेगा। तो इसमें कई सारे मेन टॉपिक्स हम कवर करेंगे और चैप्टर वाइज इसमें रिवीजन होगा। तो जल्दी से आप जुड़ जाइए और इस रिवीजन में आप भी प्रतिभाग कर सकते हैं अपने कमेंट के माध्यम से। तो स्टार्ट करेंगे पहला चैप्टर क्लास 10th सब्जेक्ट साइंस सीबीएसई बोर्ड सब्जेक्ट कोड 086 सेशन 2023-2024। तो पहले चैप्टर से स्टार्ट करते हैं। तो फर्स्ट चैप्टर हमारा यहाँ पर है केमिकल रिएक्शंस एंड इक्वेशंस। सो फर्स्ट डेफिनेशन हम डिस्कस करेंगे। व्हाट इज़ केमिकल रिएक्शन? Chemical changes or chemical reactions are the changes in which one or more new substances are formed. Chemical equations, representations of a chemical reaction in terms of symbols and formulae of the reactants and products is known as chemical equation. Balanced chemical equation. The chemical equation in which the number of atoms of different elements is same on both sides of the arrow is called balanced chemical equation. For balancing of a chemical reaction, we use heat and trial method. Balancing of chemical reaction is depending on law of conservation of mass. The chemical reactions can be classified into different types such as first, combination reaction. The reaction in which two or more substances combine to form a new substance are called combination reaction. For example, 2Mg plus O2 gives 2MgO. Decomposition reaction. A single reactant breaks down to yield two or more products. Decomposition reaction can be of these types like thermal decomposition, electrolysis, photochemical reaction. So here example is given, you can see. Now next we have displacement reactions. The chemical reaction in which a more reactive element displaces a less reactive element from a compound are known as displacement reactions. For example, Zn plus CuSO4 gives ZnSO4 plus Cu. Second, Cu plus 2AgNO3 gives CuNO3 2 plus 2Ag. Double displacement reactions. The chemical reactions in which compounds react to form two different compounds by mutual exchange of ions are called double displacement reactions. These reactions take place in solution. Two common types of this reaction are precipitation reaction and neutralization reaction. Precipitation reaction. In this reaction, aqueous solution of two salts are mixed, whereby some salts precipitate due to mutual exchange of ions between the two salts. For example, BaCl2 plus Na2SO4 gives BaSO4 plus 2NaCl. Here BaSO4 is a precipitate. Second, neutralization reaction. In this type of reaction, an acid reacts with base to form salt and water by exchange of ions. NaOH plus HCl gives NaCl plus H2O. Next, redox reaction. Chemical reaction which shows both oxidation and reduction reaction. Oxidation, reaction that involves the gain of oxygen or loss of hydrogen. Reduction reactions that shows the loss of oxygen or gain of hydrogen. Both oxidation and reduction take place simultaneously and hence called redox reaction. ZNO plus C gives Zn plus CO. ZNO reduced to Zn reduction and C oxidized to CO oxidation. What does one mean by exothermic and endothermic reaction? Give examples. Exothermic reaction, a chemical reaction in which heat energy is produced. Example, C plus O2 gives CO2 plus heat is released. Endothermic reaction, a chemical reaction in which heat energy is absorbed. Example, CaCO3 plus heat gives CaO plus CO2. Corrosion, the process of slow conversion of metals into their undesirable compounds due to their reaction with oxygen, water, acids, gases, etc. present in the atmosphere is called corrosion. Rusting, iron when reacts with oxygen and moisture forms red substance called rust. Define rancidity, how it can be prevented. So this definition is an important one. Rancidity, the taste and odor of food materials containing fat and oil changes when they are left exposed to air for a long time. This is called rancidity. It is caused due to oxidation of fat and oil present in food material. It can be prevented by using various methods such as by adding antioxidants to the food materials, storing food in airtight container, and by flushing out air with nitrogen. Let's move to the next chapter. Acids and bases. Salts. The word acid comes from the Latin word acid, which means sour. Acids are sour in taste, turn blue litmus red, and dissolve in water to release H plus ions. Example HCl, H2SO4, HNO3, etc. are example of acids. Bases are bitter in taste, have soapy touch, turn red litmus blue, and give hydroxide ions in solution. Example NaOH, KOH. A salt is a compound which is formed by neutralization reaction between an acid and base. Example sodium chloride, NaCl. Indicators. Indicators are substances which indicate the acid or basic nature of the solution by their color change. The color of some acid base indicators in acidic and basic medium are given below. Indicators: litmus solution. Color in acidic medium red. Color in basic medium blue. Methyl orange. Color in acidic medium pink. Color in basic medium orange. Phenolphthalein. Color in acidic medium colorless. Color in basic medium pink. Methyl red. Color in acidic medium yellow. Color in basic medium red. Chemical properties of acids. Acids react with active metals to give hydrogen gas. Example Zn plus H2SO4 gives ZnSO4 plus H2. Acids react with metal carbonate and metal hydrogen carbonate to give carbon dioxide. NaHCO3 plus HCl gives NaCl plus H2O plus CO2. Acids react with bases to give salt and water. This reaction is called as neutralization reaction. NaOH plus HCl gives NaCl plus H2O. Acids react with metal oxides to give salt and water. CuO plus H2SO4 gives CuSO4 plus H2O. Chemical properties of bases. Reaction with metals. Certain reactive metals such as zinc, aluminum, and tin react with alkali solutions on heating and hydrogen gas is evolved. 2NaOH plus Zn gives Na2 ZnO2 plus H2. Reaction with acids. Bases react with acids to form salt and water. KOH plus HCl gives KCl plus H2O. Reaction with non-metallic oxides. These oxides are generally acidic in nature. They react with bases to form salt and water. 2NaOH plus CO2 gives Na2CO3 plus H2O. pH scale. The full form of pH is potential of hydrogen. The concentration of hydrogen ion in solution is expressed in terms of pH. The pH of a solution is defined as the negative logarithm of hydrogen ion concentration in moles per liter. pH equals to minus log H plus. Importance of pH in everyday life. Our body works within the pH range 7 to 7.8. When pH of rainwater is less than 5.6, it is called acid rain. HCl produces in our stomach which helps in the digestion of food. Sometimes stomach produces too much acid and this causes pain and irritation acidity. To get rid of this pain people use antacids. Magnesium hydroxide milk of magnesia. So this is an important question. You may find in MCQ. That is question you may find in this form that what is the chemical in antacids. So magnesium hydroxide which is also known as milk of magnesia. So I think you have noted this thing. So this is a very important one. You may find this in the examination. Now third point. Tooth decay starts when the pH of mouth is lower than 5.5. Tooth enamel made up of calcium phosphate is the hardest substance in the body. Bee sting have formic acid, methanoic acid which causes pain and irritation. Use of mild base, baking soda gives relief. For water neutral solution pH equals to 7. For acidic solution pH is less than 7. For basic solution pH is greater than 7. Some important chemical compounds. Common salt NaCl. Common salt. Sodium chloride is known as common salt. Its main source is seawater. It also exists in the form of rock sand, is called rock salt. Common salt is an important component of our food. It is also used for preparing sodium hydroxide, baking soda, washing soda, etc. Now next we have sodium hydroxide or caustic soda NaOH. It is prepared by passing electricity through an aqueous solution of sodium chloride known as brine solution. So chemical equation 2NaCl plus 2H2O gives NaOH plus Cl2. This process is known as chloralkali process. Bleaching powder. Formula is CaO. Chemical formula is CaOCl2. Its chemical name is calcium oxychloride. It is prepared by passing chlorine gas through dry slaked lime. CaOH2 plus Cl2 gives CaOCl2 plus H2O. Now we will discuss the uses of bleaching powder. For bleaching cotton and linen in textile industry and wood pulp in paper industry. For disinfecting drinking water. Next compound is baking soda NaHCO3. Chemical name is sodium hydroxide sodium hydrogen carbonate. It is prepared by passing CO2 gas through brine solution saturated with ammonia. NaCl plus H2O plus CO2 plus NH3 gives NH4Cl plus NaHCO3. Now properties of baking soda. It is white crystalline solid and sparingly soluble in water at room temperature. On heating, it decomposes to give sodium carbonate and carbon dioxide. It reacts with acids to give carbon dioxide gas. Its aqueous solution is weak alkaline due to hydrolysis. Now it is used in soda acid fire extinguisher. It acts as mild antiseptic and antacid. It is used as component of baking powder. In addition to sodium hydrogen carbonate, baking soda contains tartaric acid. Next compound is washing soda. Washing soda chemical formula is Na2CO3.10H2O. Chemical name is sodium carbonate decahydrate. It is prepared by heating baking soda. Recrystallization of sodium carbonate gives washing soda. 2NaHCO3 gives Na2CO3 plus H2O plus CO2. Na2CO3 plus 10H2O gives Na2CO3 dot 10H2O. So here you need to check this particular. Okay, now next uses of washing soda. It is used for removing permanent hardness of water. It is used in glass, soap and paper industries. It can be used as a cleaning agent for domestic purposes. Next one, very important, plaster of Paris. Chemical formula is CaSO4.12H2O. Its chemical name is calcium sulfate hemihydrate. So you must remember this, calcium sulfate hemihydrate. It is obtained by heating gypsum up to 373 Kelvin. CaSO4.2H2O gives CaSO4.12H2O plus 1.5 H2O. On treatment with water, it is again converted into gypsum and sets as a hard mass. So reaction you can see, CaSO4.12H2O plus 1.5 H2O gives CaSO4.2H2O. Now we will discuss the uses of plaster of Paris. It is used by doctor for setting fractured bones. It is used for making statues, models and other decorative materials. Now chapter number 3. So student, right now a quick revision is going on of science. So I hope this will definitely help you in your exam. So you can learn a lot from this. Now we will discuss next chapter, metals and non-metals. Elements are classified broadly into two categories on the basis of properties. Metals like iron, zinc, copper, aluminum, etc. Non-metals, chlorine, nitrogen, hydrogen, oxygen, sulfur, etc. Apart from metals and non-metals, some elements show properties of both metals and non-metals. Example, silicon, arsenic, germanium. They are called metalloids. Gold is the most ductile metal. Silver and copper are the best conductor of heat. Mercury is a metal which is present in liquid state. Lithium, sodium and potassium can easily cut with a knife. So these are very important. You must remember because you may find this in your exam in the form of MCQ. Okay. In case study also you may find. So you must remember all this. Very important. Now reactions. Reaction with oxygen. Metal plus oxygen gives metal oxides. Metal plus oxygen gives metal oxides. So some example we can discuss. 4Na plus O2 gives Na2O. 4Al plus 3O2 gives 2Al2O3. Metals form basic oxide. This is also an important point. Metals form basic oxides. And non-metal forms acidic oxides. Some of the example related to non-metal we can discuss. C plus O2 gives CO2, S plus O2 gives SO2. Amphoteric oxides. Zinc and aluminum form amphoteric oxides. They show the properties of both acidic and basic oxides. Non-metals form acidic oxides. CO and H2O are neutral oxides. They are neither acidic nor basic in nature. Non-metal oxides are soluble in water. They dissolve in water to form acids. SO2 plus H2O gives H2SO3. Now reaction with water. So metals react with water to form metal oxides or metal hydroxide and H2 gas is released. Nonmetals do not react with water, steam to evolve hydrogen gas. Because nonmetals cannot give electrons to hydrogen in water so that it can be released as H2 gas. Reaction with dilute acids. Metal plus acid gives metal salt plus hydrogen. So some examples are given here. 2Na plus H2SO4 gives Na2SO4 plus H2. Metal plus HNO3 gives H2 gas is not released. So in case of HNO3, H2 gas is not released. Reason HNO3 is strong oxidizing agent. Mn plus 2HNO3 gives MnNO32 plus H2. Nonmetals do not react with acids to release H2 gas. Reason nonmetals cannot lose electrons and give it to hydrogen ions of acid so that the gas is released. Reaction with salt solutions. When metal reacts with salt solution, more reactive metal will displace or less reactive metal from its salt solution. CuSO4 plus Zn gives ZnSO4 plus Cu. When nonmetal react with salt solution, more reactive nonmetal will displace or less reactive nonmetal from its salt solution. 2NaBr plus Cl2 gives 2NaCl plus Br2. Reaction with chlorine. Metal plus chlorine gives metal chloride. Ionic bond is formed, therefore ionic compound. Non-metal plus chlorine, non-metal chloride covalent bond is formed, therefore covalent compound. Now let's just see the formation of magnesium chloride ionic compound. So you know that whenever there is an ionic compound, there is a transfer of electrons. So you can see there is a transfer of electrons. Okay, so MgCl2 plus 2Cl. So ultimately MgCl2. Okay, so MgCl2 compound will form when one atom of magnesium reacts with two atoms of chlorine. Properties of ionic compounds. Physical nature. Solid and hard due to strong force of attraction. Melting point and boiling point. Have high melting and boiling point. As large amount of heat energy is required to break strong ionic attraction. Solubility. Soluble in water and insoluble in kerosene and petrol. Conduction. Conduction of electricity. Ionic compounds in solid state does not conduct electricity. Reason ions cannot move due to rigid solid structure. Ionic compounds conduct electricity in molten state. Ions can move freely since the electrostatic forces of attraction between the oppositely charged ions are overcome due to heat. Now student, we will discuss very important chapter carbon and its compound. So many questions you will find in the examination. Important terms. Versatility of carbon. Carbon is non-metal and occurs in free as well as combined state in nature. Free state, diamond, graphite and coal. Combined state, solid state, all animals and plant products. Liquid state, petroleum and vegetable oil. Gaseous state, CO2 in air, methane, ethane. Carbon cannot form C4 plus and C4 minus. Why? Carbon has 4 valence electrons. It cannot form an anion C4 minus by gain of electrons. It cannot form C4 plus by loss of electrons. It can share its valence electrons with other carbon atoms or other atoms of non-metals to form covalent bonding. Compounds of carbon. Simplest compounds of carbon are hydrocarbons. Compounds which consist of carbon and hydrogen atoms only are known as hydrocarbons. Simplest hydrocarbon is methane, CH4. Classification of hydrocarbon. Saturated hydrocarbon, unsaturated hydrocarbon. In saturated hydrocarbon we have alkenes. General formula CnH2n plus 2. Compounds having single bond CC, example ethane. Unsaturated hydrocarbon alkenes. So here we need to check. So in saturated hydrocarbon we have alkane, and in unsaturated hydrocarbon, so here is one mistake, so it must be alkane. Okay, unsaturated hydrocarbon alkenes and alkynes. Alkenes general formula CnH2n, alkynes general formula CnH2n minus 2. Compounds having double and triple bonds comes under unsaturated. Ethene C2H4, ethine C2H2. Now, important definition, that is, or important term that you must know, that is isomerism. The phenomena of existence of compounds in two or more forms with same molecular formula but different structure. Versatile nature of carbon. The existence of such a large number of organic compounds is due to the following nature of carbon. First is catenation, self-linking property. Second is tetravalent nature. Catenation. The self-linking property of an element, mainly carbon atom, through covalent bonds to form long, straight, branch and rings of different sizes are called catenation. This property is due to the small size of the carbon atom, the great strength of the carbon-carbon bond. Carbon can also form stable multiple bonds, double or four. Carbon has valency of 4. It is capable of bonding with 4 other atoms of carbon or some other heteroatoms with single covalent bond as well as double or triple bond. Properties of homologous series. A series of compounds of same functional group in which two consecutive members are differ by CH2 group in molecular formula and by 14 in molecular mass. Covalent bond. The bond which is formed by sharing of electrons is called covalent bond. Covalent compounds. The compound which is formed by covalent bond is called covalent compound. Now next chapter we have life processes. Autotrophic nutrition. First we will discuss autotrophic nutrition. Okay. So it is a kind of nutrition in which inorganic materials like CO2, water, etc. are utilized to prepare organic food by the process of photosynthesis. Example, green plants. Heterotrophic nutrition. Organisms do not possess the ability to synthesize their own food. They depend on autotrophs. Example, fungi. Types, holozoic nutrition, saprophytic nutrition, parasitic nutrition. Now we will discuss the difference between autotrophic nutrition and heterotrophic nutrition. Food is synthesis from simple inorganic materials CO2 and water. In case of heterotrophic nutrition, taken directly or indirectly from autotrophs. In autotrophic nutrition, chlorophyll is necessary. In heterotrophic nutrition, no pigment required. Can be prepared all times. And in autotrophic nutrition, prepared during daytime. Example, all green plants, some bacteria. And heterotrophic nutrition, all animals and fungi. Now next we have equation of photosynthesis. So I think you know this equation very well. So equation is 6CO2 plus 12H2O gives C6H12O6 plus 6O2 plus 6H2O. So this photosynthesis process takes place in the presence of sunlight and chlorophyll. Main events of photosynthesis: absorption of light energy by photosynthesis, conversion of light energy into chemical energy, plus splitting of water into hydrogen and oxygen, and last, reduction of carbon dioxide to carbohydrates. Stomata. So stomata are the tiny pores present on the surface of the leaves. Functions of stomata: exchange of gases O2, CO2, loses a large amount of water vapor during transpiration. So you must learn all this. These diagrams you can see, these are very important. You must learn all this. Now functions of glands and digestive juices. Starch is converted into glucose by salivary amylase, gastric juices. Functions of small intestine and villi. Small intestine. It is the site of the complete digestion of carbohydrates, proteins, and fats. Intestinal enzyme converts carbohydrates into glucose, fats in fatty acid plus glycerol, and proteins into amino acids. So this is very important. Intestinal enzyme converts carbohydrate into glucose, fats in fatty acid plus glycerol, and proteins into amino acids. It has villi finger projection which help in absorption of food into blood function of bile juice. Bile salts break large fat particles into smaller particles for enzyme action. Now, another important topic we will discuss difference between aerobic and anaerobic respiration. So this is a very important one. Aerobic respiration occurs in the presence of oxygen, occurs in mitochondria, and products are water and carbon dioxide, more amount of energy released. In case of anaerobic respiration, occurs in the absence of oxygen, occur in cytoplasm and products lactic acid and alcohol, less amount of energy is released. So, thank you very much for joining today's session.